Hello and welcome to Space Shark Teaches. I'm Sean from Space Shark Studios, and I'm here to teach you GD Script in Godot 3.1. Let's get started.
In this lesson, we will be updating the player movement script so that the player's movement is smoother and more realistic and similar to Marble Madness. So to start, we want to go through and make sure that our ball is set up correctly for the new controls that we're putting on it. And partly that means going into physics and making sure that some of these settings are as so. Make sure that your friction is back to 1. Go ahead and turn off roughness. So reset that. Make sure all of this is basically back to where it needs to be. And after that, we're going to go down here to this angular and make sure that our damping is 0.8. So what damping means is, let's say you're rotating this way. So you see the blue, that's the z-axis. So let's say you're rotating left or right across the z-axis. That rotation is going to be slowed down 0.8 per frame or cycle, not sure which, but play with this number and you'll be able to control how quickly things stop spinning one way or the other. And that's really important because we're going to be changing the script to, instead of being based on, as you can see right here, this impulse, we're going to be controlling the rotation in order to move it. So in order to do that, let's go ahead and start making changes to this code. So to start with, we are going to add a couple more variables up here. So export variable speed and set that initially to 45. Export variable max speed, and that's going to be 15. Let's just go ahead and go ahead and set that to something that makes more sense. So rotational speed. So that means how fast we're going to be rotating every time this process input gets called. Because we're going to be changing this movement input. So we've normalized it already. So then we are going to do a couple things. One is normalize it by the delta. The delta is the time between the last time this function was called and this time. So this allows us to have a much more normalized speed where jumps in frame rate aren't going to cause your ball to go different speeds. And then we're going to multiply it by the rotational speed. And so that is how we will get our overall rotation. And now that we're done with that, we're going to go down here. Let's go ahead and comment this out. And we are going to instead be adding something called apply, or we're going to be making a new variable, called torque. And that is going to be a new vector 3, which is going to be around the movement input z-axis, which is the x. So remember, if we have x, y, and then z is this kind of forward looking, the x angle is the one that goes left and right. If we spin around that, that means we're rolling forward. So we want that as our z here. So we're going to be using our z speed, which was initially forward and backwards, and we're going to be saying do that, but rotate it around the x-axis right here. And same thing with z over here. So if we're going to be rotating this way, so rotating it left and right, that is around the forward and backwards z angle, or z-axis. So we're going to be using this. And that kind of swaps the directions that we're spinning around. Now using that, we want to do apply torque impulse of our torque. We're going ahead and Control S to save, and then press P, or press the play button. And now you can see that we have this ball that spins around. And I forgot one setting that is very important. So in all of this, we have our mass, we have our physics, we have our dampening, gravity scale. Setting that higher will cause the ball to stick better to the floor because it's increasing how much gravity is actually applied. So weight and mass and all of that, you can skip past that and just go straight to how hard or how down is the gravity. So that will allow it to stick a lot better. As you can see, we're pressing down. W makes it move forward, D to the right, S down, A to the left, and now we are sticking to the ground. All nice. So the only problem with this now is, let's say we had an infinite board here. I can make it kind of just show it off. But let's say our walls were gone and our floor had, floor of 400 by 400, and the collision shape was 200 by 200. You can see, those walls are invisible, but they are still there. All right, let's go ahead and move them down. You can see they kind of just, it speeds up forever. It was starting to come back. So let's go ahead and Control Z to get those back to where they were. So now we're back to where we were, and we're going to be actually editing the script for the ball one more time. And we're going to be adding in some absolute values here. So what we're going to do is, before we apply our torque, we are going to check if the absolute value of our linear velocity in the x direction is greater than our max speed. Then we want, if we look down here, then we want our movement input x to be 0. And if linear velocity z is greater than max speed, then our movement input in the z direction should be 0. And so in order to test this, go ahead and set the max speed to something low, like 5. And you can see now it is clamped. If we set this up to something like 10 and restarted, you can see that we can move faster now, about twice as fast, which is right. And this is how you can go and balance your game to say, what is a good feel for that speed? I chose 45-15 because it gives enough of an acceleration, which is really what that rotational speed is. It's that acceleration rate, as well as a max speed high enough for you to make mistakes if you decide to roll down a hill too quick or keep pressing the button too long before trying to get up onto a surface. Because remember, we're making a Marble Madness sort of game out of this. And so that is it for right now. Make sure and come back for our next lesson, which is going to be coming up really soon, which is on adding a follow camera so that you don't have to have one fixed position camera like we have right now. All right, see you then.
Thank you for watching Space Shark Teaches. If you'd like to see more, please subscribe to the channel and remember to click the bell to always stay up to date. Please also join us on our Discord, linked in the comments, and check out our other videos if you ever want to see what else we've been up to. Thanks again for watching, and we can't wait to see what you make.